Good morning to one and all present here. As a part of continuous improvement, we are having this lecture series in the course Engineering Materials. So today we are going to discuss about testing of materials. So when we use some materials for building up an aircraft or ship or any other automobiles, so we need to test some properties. So these properties are very important whenever that automotive component is subjected to a load. So today we are going to see about this tensile test. So tensile, compressive and shear are the three loads that are being constantly applied on any material. So when we pull up a material on either side of that, so the material experiences a tensile load where there is an increase in length and there is an elongation. So here we have a picture of universal testing machine where we have upper crosshead, space for tensile specimen, movable crosshead, face for compressive specimen, and load indicator, speed control, and table. So when we look into this universal testing machine, why it is called universal testing machine is in the sense we can test all the specimens in one machine. So actually what happens in this test, we will see with the flow chart. Coming to the first point in the tensile test. So a tensile test, also known as tensile test, tension test, it is a mechanical test used to determine behavior of materials under tension. It is one of the most common and fundamental tests performed on materials, especially metals, to understand their mechanical properties. So in a tensile test, a test specimen of specific shape and dimensions, usually in the form of cylindrical or rectangular bar, is subjected to an increasing universal tensile force. The specimen is gradually pulled apart along its longitudinal axis until it fractures. It's a beautiful test where you can see a material gets elongated and there comes a point where it breaks. During the test, various mechanical properties and behavior of materials can be measured and analyzed. So we have a step-by-step description of typical tensile test. The first point in the test is to be prepare a standardized specimen according to standards. We follow ASTM standards, and for the tensile test, we have E8 as the standards. The specimen is machined into a specific shape and dimension, including a reduced section in the middle called gauge section. So we call it as gauge section here, and the diameter of the round rod at the ends are greater than the middle section. Then we are going to mount the specimen in a tensile testing machine. So the machine consists of grips or clamps at the end of the specimen to hold it firmly. And there comes the application of load in the next part. The tensile machine applies an increasing axial tensile force to the specimen. The force is gradually and continuously applied until the specimen fractures. So the load is generated using either hydraulic or electric motor. So there comes the deformation or elongation of the specimen. So the next step in the process is to measure stress and strain. So we all know what is stress and strain. So the machine calculates and records the stress and strain values. Strain is the force per unit area typically expressed in megapascals, and strain is the ratio of change in length to the original length. So then after recording the loads, when the specimen fractures, that is called ultimate tensile strength. So then we have to plot the stress strain curve for the material. The stress strain data obtained during the test are plotted in a graph. The curve provides valuable information about the material's mechanical properties, including its elastic behavior, yield strength, ultimate tensile strength, ductility, and fracture points. So the analysis of results stage, we are going to determine several mechanical properties which are very important for construction of any material that is used in engineering field. So yield strength, ultimate tensile strength, ductility, and toughness. These properties help characterize the material's response to the tensile loading and provide insight to the suitability for specific applications. So in general, tensile testing is widely used in material science, engineering, and manufacturing industries to evaluate and compare the mechanical properties of different materials, ensuring the quality and guide material selection for specific applications. So we'll go to the next slide where a tensile test has been conducted in low carbon steel and a plot is generated. Here we have in the x-axis strain and y-axis stress. So the tensile specimen, when it is loaded, the stress and strain is gradually increasing in a linear manner up to a point called proportional limit. So here we should understand the stress and strain is increasing correspondingly equally with a small variation, so that we are getting a straight line, and this straight line up to the proportional limit, Hooke proposed a law, that is Hooke's law. Within the elastic limit, there comes the stress is directly proportional to the strain. So this is the statement of Hooke's, who proposed this law. So after the proportional limit, there comes an upper yield point and the lower yield point, where the material starts yielding itself towards the load. Then there comes strain hardening, where the material is experiencing immense load to get fracture. So getting into the point where there is that the specimen can hold the maximum strength, where it is called the ultimate tensile strength, there happens necking, and finally the material gets a fracture and departs. So here you can see the picture of two single specimen is being cut into two pieces. So this material fails at this point. Fracture point is the point where the stress is maximum and the strain is getting minimum and the material fails. So for every element or every metal in this earth which is used in engineering field, it has to be subjected to this tensile test to find the ultimate strength of the material. That will serve the purpose of usage in the engineering field. So a lot of engineering components fails at one point where there may be a loss of life or catastrophic failure. To avoid this, all these things, every engineering material is subjected to different mechanical properties tests. And this is one of the beautiful tests which is to be seen practically as our students see in our lab at the end. So thank you all for joining in this lecture series. Save trees, save nature. Thank you.